Dear all, this lecture is on signals and systems. In signals and systems, we are studying first signals. So today in this lecture, we will study how we can represent any signal by using basic signals or elementary signals. Okay, so this just sharing my screen, and we will discuss the representation of signals using elementary functions. Okay, I hope everything is visible to you, and first thing is that content. So we have seen in the earlier classes how can we represent a signal, and then we have seen in the earlier classes that how can we how can we do the operations, basic operations like addition, subtraction, multiplication, division, all these operations, time reversal, time scaling, we have already understood. So everything is clear now. Now today's topic is representation of any signal using elementary signals, or these are called also singularity functions or singularity signals, or benchmark signals, or basic signals, like that. What are those basic signals, or standard signal, or benchmark signal, or singularity signals? Unit step signal, unit ramp, unit impulse, rectangular, Gaussian, exponential. These are. So we want to represent any signal by using either unit step or unit ramp or unit impulse, like that. Okay, let us take one example to understand this. A simple example we will take to understand this concept. Okay, so we will represent using unit step signal first. So we all know what is the unit step signal. Please pause this video and write in your notebook about unit step signal. Okay. When you complete writing, you can just again start this video and continue. So, okay, in the meantime, I will write for this. So, unit step signal is a signal which starts from 0. So, this is represented as xt equal to 1 when t is greater than or equal to 0, and 0 when t is less than 0, like this. This is a unit step signal. Now we have to use this signal, unit step signal, to represent any other signal. For example, if we have a signal like this, so for this signal xt shown in the figure below provide mathematical equations in terms of step signal. You will get question like this in the exams. So how can we do? What can be the method to represent this signal in by using unit step signals? Okay, so what we can do, we can just start writing from the left side, from -1. At -1 we can see that a unit step function starting at -1 is there in this problem. So I can write a unit step function starting from -1 first. So unit step function starting from -1 is written as u of t plus 1. See, starting from left side means +1, starting from right side means -1. Okay, so this will go to till infinity, but we want to stop it at 1. So what I have to do, I have to add another signal in this signal which can make it 0 at 1. So I have to add minus 1 value at t equal to 1. When I add minus 1, then this one will become 0. Okay, so what will be the equation for this signal? U of minus of u of t minus 1. Isn't it? So combinedly, what we can write? We have to add these two. So if I add these two, I can write x of t overall what can be written? X of t is equal to ut plus 1 minus u t minus 1. Isn't it? Is this okay? That means this signal, this rectangular signal can be written as u t plus 1 minus u t minus 1. Okay, so this is the solution for this. Now next question, example number 2. The second example is that for the signal given below, give mathematical equations in terms of step signal. Again it is written that you have to write this xt by using step signals. Previous one you have understood. Therefore, pause this video here and write equation for this. Okay. So you just try to write equation for this one, this problem. This is another example. So before going to that example, I will take new slide here and I will try to solve this. So you can see here that one step function of value 1 is starting at minus 1. So I will write first one as u of t plus 1. So this will this signal will become like this, u of t plus 1. At minus 1 by 2, what is happening in this signal? At minus 1 by 2, it is becoming 2. That means 1 is added at this point. So I will again add 1, u of t plus 1 plus u of t plus 1 by 2. Then this signal becomes like, so from minus 1 it was minus 1, and at 1 by 2, minus 1 by 2 it is becoming 2. Now it is 2. So signal is like this now. But again you can see that what we need actually now it should go down. When it should go down at 1 by 2, it should come back to 1. So it is 2 and you want to make it 1, so you have to reduce unit step signal by 1. So I have to subtract 1 unit step signal at 1 by 2. So u t plus 1 plus u t plus 1 by 2 minus u t minus 1 by 2. Okay, so then when I reduce t minus 1 by 2 at this point, so this should come back to this one. It will come back to this, and it will again, it is going to infinity. We have to stop it from going to infinity. So at 1, again I have to reduce by 1. So I have to write u t plus 1 plus u t plus 1 by 2 minus u t minus 1 by 2 minus u t. Ut minus 1. So means at 1, this place was 1 by 2, at 1 again it will become 0. The final diagram for this function will be u t plus 1 plus u t plus 1 by 2 minus u t minus 1 by 2 minus u t minus 1. Okay, I hope this one should be the answer for this. Next question, example 3. Again, this is a little advancement for the same problem, and I am sure that you all will be able to do it. Okay, so I hope you all will be able to do this problem, this third example, by yourself. You do not need that I should solve it. Okay, and I am also sure that your answer will be correct. Therefore, I am leaving this question for your practice. Okay, so this question is now now practice question. So I am leaving this example 3 for your practice. Or you can include this in assignment. You can say assignment or tutorials. Okay, so you can include it in tutorials. And I'm sure, I will not tell the answer. I'm sure that you will be able to do. Okay, now this equation, this answer is available, so you can note down, and but all the steps should be correct for this one. Okay, so in this way we can represent any signal, any rectangular kind of signal, by using the step signals, and you must have understood that what is the way to represent any signal by using step signal. Okay, let's go further and see how any signal which is having a slope kind of thing can be represented by using the step signal or delta signal or ramp signal like that. Okay, so one example is shown here. You can see that in this example, this is a positive sided signal only. So signal is starting from 0. It is not available in the negative side of the spectrum. It is available only in the positive side of the spectrum, and then we can see that how can we decompose it into the small signals, and how those signals will be useful for the proper classification, for the proper representation of the signal by using the basic signals. Okay, so let me take it. So ut, then u of t minus 1. So adding both will become now 2 from t equal to 1, and then reducing it by minus 3 at t equal to 2 will result in this whatever is shown here. This one is result ut plus u of t minus 1 minus 3 ut minus 2. Now at 3 we need to have one ramp signal instead of this straight line, so we have to change it. We have to add one you can say this triangular signal rt minus 3 at 4. Okay, and then only this will be completed. This representation will be completed. Okay, so now you can write that x of t is equal to ut plus ut minus 1 and plus rt 4. Okay, so this is the answer for this. Okay, now representation of some other signals by using basic signals. हम थोड़ा सा एक बेसिक रिकैप इसका भी देख लेते हैं, और ये भी आपकी प्रैक्टिस के लिए ही है. यू कैन प्रैक्टिस दीज ऑल with the help of unit step signal or ramp signals. You can represent the all kind of circuits. Okay, so by using basic signals, these all kind of circuits can be represented. Now one practical question based on representation of signal. In a network of given figure, this is a constant current source and switch is closed at time t equal to 0. Express the capacitor voltage VCT as a function of the unit step. Okay, so this is saying that you have to first calculate the capacitor voltage, then you have to represent it by using this VCT. By using VCT. So VCT is a function of unit step signal. ओके, हम लोग इसको शॉर्ट में देख लेते हैं, इसका सोल्यूशन कैसे निकालेंगे. दैट इज लेट मी टेक वन स्लाइड एंड it's clear now, and this also removed. So the voltage at the capacitor VCT, we know that this is equal to 1 by C integration minus infinity to infinity ICT dt. Because the switch is closed at edge, switch closes at t equal to 0. So IAT equal to IS UT. Okay. So I of ICT equal to IS of UT. करंट इक्वल होगा पूरे सर्किट में, जो जितना कैपेसिटर से फ्लो होगा वही रेजिस्टेंस से फ्लो होगा लाइक दैट. सो द वोल्टेज इक्वल टू 1 अपॉन C माइनस इन्फिनिटी टू इन्फिनिटी ICT dt. Okay, so this is equal to VCT equal to 1 upon C minus infinite to T IS W. Okay, so this is the 1 upon VCT 1 upon C minus infinity to T minus infinity to T only available. So IS into U of T dt. This is 1 upon IS upon C Okay, so this is the voltage across capacitor ICT into UT dt. Now this will be I of S upon C minus infinite to 0 U of tau d tau plus 0 to infinity U tau d tau. Okay, now you can say that minus infinity to 0 is 0, and from 0 to infinite we can calculate that This is equal to Vc of t equal to okay, so this is equal to Is upon C T TUT. Okay, this is the Vc T voltage across capacitor. Okay, this is the represent how we can represent the elementary signal. So this is one of the representation. Now let us see how can a unit step function is useful for the practical understanding of the signals. Okay, and one more example I will take for sketching. This kind of a periodic waveform is written in the question, and it is asked. The question is that express this in terms of unit step function. Express the square waveform as a sum of unit step function. So a square waveform is given. This is periodic square waveform. So this period is available only in the current stages, t, 2t, and 3t, 3t, and like that. Okay, so this is A and this is minus A. Okay, and this signal is continuous. This is continuing like a waveform. Okay, so what will the representation for this? X of t equal to, first of all, ut, and then x of t equal to ut जाएगा infinite तक, फिर u of t minus u t minus t by 2. Okay, because the first one you have to do the minus, so minus not at t by 2 but at t you have to reduce. How much you have to reduce? This will be 2 times, because you have to go below, 2 times u of t minus t. So I can take a completely common, ut minus 2ut minus t plus 3 pi के बाद minus okay, then this one is sufficient. Okay, this is the representation of signal in terms of unit step function. Okay, thank you so much, thank you, and hope you will be able to do all such type of problems in future. Thank you all, thank you so much for paying attention on this lecture.